Hello. So here we are going to discuss about the problem related to binary tree leaf at same level. So in this problem we just need to check that if all the leaf nodes of our binary tree are at the same level. So you can see the example number 1. Here we have 1 as a root node and 2 leaf nodes as 2 and 3. You can see that level of one row, that is root node, is 0 and level of 2 and 3 is 1, and both are at the same level. That's why we output as 1 or 2. Similarly, you can see this example number 2, where this is root node and leaf nodes are 10, 15 and 30. But 10, 15 are at the level 2 but 13 is at the level 1. That means all the leaf nodes are not at the same level. That's why we return false. So how to find how to check that all the leaf nodes are at the same level? So let's consider this. In this uh, question, how are we going to approach this? So we are traveling throughout the tree, doing pre-order traversal. Whenever we encounter a leaf node, we will keep track of the level. So first of all, level at root node is 0, and so if we go left or right, we increment the level as 1. Again, even if we go here left, or if we go right, we increment the level plus plus. So that's what we are going to do. At the end, once you encounter a leaf node, we are checking that uh, once you encounter the leaf node, we are checking that the level of this leaf node and level of the previous leaf node. If both the levels are same, then it's okay. So throughout our journey, if we encounter a case that the level of the previous leaf node is different from the level of the given leaf node, then we are returning false, and that's where our function stops. So you can have a doubt that for level to compare a level of current leaf node with previous leaf node, we should have a previous leaf node. But in this case, if we encounter the first leaf node uh, in our traversal, so there is no previous leaf node to compare with. So that's why we are maintaining a ma variable where we are initializing it with -1, just to make sure that we are if we visit just to make sure that if we visit leaf node first time, so we have to compare. We don't have to compare it with any previous node. We just have to initialize that value to the ma value. That means ma value get updated with the level of the first leaf node. So that is the level of the first leaf node is 2. It is getting updated with 2. So again, you can see the pre-order traversal. I have gone from here to here, I have gone from here to here. Now I will go again here, okay, and I will go to right. So when I go to right, I'm again having a leaf node, but now I can compare this leaf node with a previous leaf node. How can I compare? Because the level of the previous leaf node is I'm storing it in the ma variable. So ma variable stores the level of the previous leaf node. Alright, so that's what I'm just keep checking level as I'm encountering the leaf node. I'm keep checking that the level of the current leaf node and the ma value. If it matches, then it's okay. If it doesn't match, then I'm returning false. So let's quickly jump to the code that then you will understand very better. So you can see here that I'm using a function to do all these things. So you can see in this, I'm having a root node, I'm having L, that is level. I am also having a ma variable, just to make sure, just to for the condition that if I encounter the first leaf node, to handle that condition, I am having this ma variable. Okay, so the first is very simple. If there is no root node, I will just return. So this is the condition for a leaf node. If you don't have a right or left children, then it is a leaf node. Now you can see here that this is the condition to handle first leaf node. If ma equals to -1, I will simply update ma with the leaf node like here. So this is the first time where you encounter leaf node. At, at that time ma was -1. I will update that ma from -1 to 2. So that's what is done over here. So if that is not the case, that leaf node I am visiting is not the first leaf node, then I will just check for the condition that throughout my traversal at any of the point of the leaf node, if the level is not equal to my ma variable. What is the ma variable? Indicate the level of the previous leaf node. If this is false, that means level of the current leaf node is not equal to the level of the previous leaf node. At any point of time, I will set this global boolean variable as false. Okay, so yeah, so I will not set true even if the latter leaf node satisfy the condition. So that's why my answer variable get false, and I am recursively calling same thing from root left. So again from root to root ka right. So and I am keep updating the level at every recursive call. So this is simple pre-order traversal. The pre-order traversal में क्या होता है कि first of all you have data and you can do whatever you want to do with the data. That is check for a condition, do some operation on that data and whatever. And then you call recursively call for left children and then recursively call for the right children. That is the pre-order traversal. And yeah, so till now our global answer boolean variable is set to false. If I just like initialize this variable, that is ma to -1, and a level starting from at the starting my level will be 0, and I will just call the function. This function will do everything for me. That is, it is going to set that boolean variable to false or true, whatever. So that will be my answer. That answer boolean variable stores my answer. That will check that if all the leaf nodes are at the same level. If it is, then it returns true. If it is not, then it returns false. So I will compile the program. I guess you will not able to see it. Yeah, now you will be able to see it. It is compiled. 1 2 3 के लिए it returns true. Yeah, you can see that 1 2 3 के लिए it returns true because 2 and 3 are the leaf nodes that are at the same level. Submit करके देखते हैं. Let's see what happens. Yes, you can see that's green tick. Yes, it's true. So that was it for this leaf at the same level question.